And I'd like to introduce Steve Bogol from Notre Dame. He is going to be talking about the 100 gig project that they've just recently started or completed. And we'll do what we did last time. Everybody's going to be muted so that we can kind of control the audio quality. And if anybody has questions, just either chat me directly or hold them till the end. I think we can probably do it either way. And with that, I will hand it over to Steve to get going. And you should be unmuted, Steve.
All righty. Thank you. As Jason said, I'm Steve Bogol from the University of Notre Dame. I work for the Center for Research Computing. And I'd like to talk about how we got our 100 gig installed and kind of what we use it for in creation of our scientific DMZ. So the first thing is, what is the CRC? If you go to our crc.nd.edu website, this is the definition that you would see. Pretty much what we do is faculty members, get their grants from their great ideas and their research, and they need web portals or software created to help support their grants. Normally they come to us for those type of resources. We have an army of developers that they can hire to build their web portals, to help build their databases and things like that. And then sometimes we host, either on physical or virtual hardware, their sites for them and help them maintain them. So the main thing is I work for the CRC, and I do not work for the central IT department of Notre Dame, which is we refer to as the OIT, or the organizational IT. The CRC itself is made up of these four groups. Like I said, the software engineering group, which is also known as our cyber infrastructure team. Then there's the HPC group, which runs the supercomputing, all the clusters. We have a group within that helps support our users so that they can run their software, help debug their software, things like that, or use the software we provide. We have our computational scientists. They're just that, computational scientists. They get grants, have domains of expertise that they help other faculty members in. And then what's kind of new to us is the social research, the computational social sciences, which was another center on its own, but kind of merged with us. My role in the organization is I'm an HP engineer in the operations side. So I work a lot with the physical hardware and virtual resources. My focus is actually virtualization. That's what I come up with, is design and implement all our virtualization solutions. I do a lot with our backups, and then I'm also one of our main networking guys. So that's how I got roped into doing this. CRC by the numbers, so we have 1,800 plus users. This can be students, grad students, faculty members, people from outside the university doing collaborative research. We kind of maintain our own set of users from the campus users. So you actually need authorization to be able to get space and resources from us and prove that you're doing scientific research. So you can't just decide that you want to store your MP3 collection on our servers and get an account and start loading them up with your data. We do have over 2,000 physical servers in our data center, which turns out to be over 25,000 cores. I mean, we have physical servers. I think our smallest now is around 12 cores per server. Every box is at least a dual socket server. And then you can go up to a quad socket server with 64 cores in it. So several major vendors, Dell, Lenovo, IBM, HP, those guys are all in there. For petabytes of data of storage, our main storage is AFS, which will kind of come into play later. And then we have other network attached storage for like such things as scratch storage. In the CRC, we have just over 45 people. We might be closer to 50 now. I'm not sure, because the cyber infrastructure side kind of changes pretty quickly. They have a lot of developers that come in and out every once in a while, and just faculty members who start here or end here or move on, things like that. On the operations side, we're pretty static. We haven't changed in years. We also support over 100 software applications on our cluster. You know, the MATLAB and all those other fun and interesting things. So the other thing is, you've probably seen on TV during Notre Dame games and stuff, all the shots of campus and, you know, the library and what they refer to as Touchdown Jesus, things like that. I am not located there at all. I am actually located in downtown South Bend on the south side of town in an old train station. And some people might ask, well, why are you in an old train station? Well, campus doesn't have a building that can support all our power and heating, all our power and cooling requirements. So they used a co-location facility. Now this facility is along the train tracks because, well, in the US, that's where all the fiber crisscrosses, right? The train's infrastructure was already there, so they just laid fiber alongside of it because the trains won't interfere with the fiber. So a lot of the fiber from like Verizon and Sprint and Comcast and stuff, all that coming from the East Coast heading to the West Coast actually runs a lot of it through South Bend and through this train station. So in the basement is a bunch of fiber vaults and where all the fiber's running. And if you look in the background, you see this old building right there? That is the old Studebaker car assembly plant. Now, the person that owns Union Station actually has recently purchased that building and is renovating it into more data center space because they're running out. Now, that building's over 1 million square feet, but not all of it will be used for data center, but a lot of it will be. So being off campus does have some pros to it. I get to park right next to my building instead of having to walk a quarter of a mile to my office, so that's not too bad. That's kind of, we have over in this corner is an interior shot, so when you first walk in, that's the grand hall. It's a neat building to work in. My office is actually up here on the second floor where I am right now giving this presentation. And then this bottom corner was just a quick picture of our data center. You can see right there where there's kind of a blank wall because we're transitioning and getting rid of some of our old servers and bringing in a new one. We have yet to purchase this new cluster that's going to fill that void. So I talked a little bit about where we're located in the old train station. Indiana, just over 10 years ago, 12 years ago, decided that they were going to link all the higher education facilities up with fiber, and they came up with the iLight network. Now, South Bend is right in the middle, all the way at the top. This is what they call the northern ring, and that's supposed to be the southern ring, but the southern ring has changed over the years, not too much into a ring is what it is now. But we're right in the middle, and we are a gigapop, which is a connection to that ring in Union Station. And you can get 100 gigabit going left or right. So if somebody drops off the ring, all the traffic just goes the other way. So it's pretty good, served us well. And that's how we get all our traffic. So before our 100 gig connection, inside our data center, this is what our network looked like. We had our Cisco 9508 core that just had a 10 gig uplink to a router that was sitting in the data center. And that data center provided our common used VLAN. So we have our private and public virtual networks, which is just for our VMs. There's another project called VectorBase. So if you go to vectorbase.org, that's actually running here in our data center. which is kind of needs disease-carrying vectors in their genome mapping. Then things, campus Wi-Fi or voice over IP. And then this VLAN actually was all our resources here in Union Station. And then that ran as a 10 gig uplink back to campus, to the campus core, which sits behind the firewall, which sits behind their routers, which has a 10 gig connection to the Indiana Gigapop. So it's kind of funny that our data center is here at Union Station, but our fiber runs back to campus, and then campus runs back to Union Station to the Gigapop for the connection. But that way we were protected behind the firewall, and life was good. However, we started having some problems. We have a group of high-energy physicists doing a CMS project, part of the Open Science Grid, OSG. And they pull down a lot of data from the supercolliders, from CERN. Now, they would pull this data down and pull it down into storage in the CRC, and then use our computational resources to do whatever they needed to do with this data. The problem is high-energy physicists have fairly large data sets. When they're pulling down information, it's just terabytes and terabytes of information. Or if you talk to a biologist, and they might say, well, I have these huge files. A lot of times to them, a big file is a couple of gigs. But to a physicist, a large file turns out usually to be a couple terabytes. So when they would start downloading their files, they were keeping the CRC uplink to campus filled up to 8 gig, which meant that the campus 10 gig link out to iLight was always filled with 8 gig. They were keeping the pipe filled 24/7 pretty much, and was only allowing campus and everyone else to use 2 gig. Didn't make people happy, but hey, that's what the pipe's there for. We were using it. Then we were starting having an increase in number of users that wanted to push all their data either in or out to other universities or nonprofits or whatever. A good example of that would be a professor either coming to Notre Dame or leaving Notre Dame, and they wanted to take their data with them. So a lot of them would have a couple terabytes of information in our system, and they would be trying to rsync that through SSH to another university, which took forever, but that's what happened. And then there were a couple incidences where we completely filled the 10 gig pipe. So we would have our physicists, and either their process would run away and fill the 10 gig pipe, or other people moving data would fill the 10 gig pipe. Now, the first couple times, we just got phone calls and were kind of told, please stop doing this. Then there was an incident, well, this is what I heard, there was an incident where they were doing an interview over Skype with a high-profile person that they were trying to woo to be a faculty member, and we killed that interview connection. And not only that, they couldn't restart it because the pipe was full. After that, some heads got together and decided we needed our own pipe just for research. Now, a few years earlier, we did ask for 40 gig, and they told us no. And then they came back and said, how would you like your 40 gig? And we said, we want 100. And reluctantly, everybody agreed to it. However, this made huge changes to our network layout. So like I said before, we had a router inside of our data center which linked back to campus. Even though it was in our data center, the CRC did not maintain that. That was part of the organizational IT, the central IT group. For us, we mainly just do, our flat networking, and we don't do a lot with routing. They were the routing experts. So they graciously came to help us and set up our 9508 to be a router. Because not only were we going now to a single routing table, we now needed 3. And there's a reason for this. So we got rid of the router, which was over here on the left side, and now the campus 10 gig is going straight into our core with a backup 10 gig into our core. And now on the other side, on the Indiana Gigapop side, we have fiber running directly into our data center that also comes directly into our 9508. Now we needed to DMZ this off so that we could have our science DMZ without affecting our other resources. So what they came up with was running 3 routing tables in our core. So all the way on our left, we have what was our normal campus VLANs, still, or, you know, our voice over IP or Wi-Fi, which we never really touch. All our virtual stuff was coming in over on this left side. So all this routes to campus, all just fine, just like normal. Then we have our compute routing table in the middle. Now you see these lines. That means these routes can talk to each other. So we moved all of our CRC resources, our computational resources, our storage, all into the center. And that can talk to anything. It can talk to what's over here in the DMZ, and it can talk to what was over here on campus. So if you want, so from here, if you had to pull something down from the internet, you can. It would flow left and out to the campus most likely. You actually had to make ports for this. So over on the bottom, it'll say 3 by 10 gig. So on our 9508, we actually have 3 cables that are just going from port to itself to create this connection. And then on the other side, we're actually doing it by 40 gigs because you want to be able to push 100 gig of networking. We were trying to match that, so we did it with 340s.
So I have a question.
Oh.
So how are those just lagged links, or how are you bonding those together in some way, or are they independent?
They're bonded.
Okay.
I believe. Once again, it was kind of the central OIT guys that went and set a lot of this up out of their kind hearts.
Now, the second part of that question is, does sort of creating that giant circle like that cause any security issues, since you're basically creating a backdoor in behind the firewall?
Well, so that's the whole kind of thing of the science DMZ was, that was the other reason why we did this, was because we don't have a firewall, device to be able to firewall off 100 gig, and the central IT didn't really want to look into that. So yes, it is kind of a security issue, but we are controlling what flows in and out through the routing tables. So through the 100 gig, we're only routing to other I2 sites and LHC1 sites.
Okay, that answers my question.
Oh, okay. So LHC1 kind of is more weighted priority. So if something comes in with a range on both tables, it should take the LHC route for sure.
Okay, go ahead, continue.
So now, when our high energy physicists want to route to Chicago and Nebraska to pull down these terabyte files, their systems are these prime radiant systems. They'll go out the right side and then go out this way towards Nebraska and Chicago to pull down their data. Where if you're just pulling down data from some type of commodity place, you're going to GitHub or Bitbucket or whatever, it's going to go this way, up and out. So the problem, and if something on this side needs to talk to something on this side for some reason, it actually has to go out to the Gigapop and then out the long way through the campus, through the firewall to get over to here, if it's routable. So that was kind of how we can keep our DMZ separate from the rest of our resources. It is a single 1 gig patch cable that's coming in with a 10 gig backup. So we don't have like the 2 links to keep stuff up, which kept costs down a little bit. All we had to do was just get 100 gig optic for our 9508. And our 9508 we've had for 2.5 years or whatever. And when we purchased it, we knew that someday we would be doing 100 gig. And that's one reason we got the 9508, was so that we could do this in the future. But so that's how our science DMZ ended up being created. So on there, I was saying we have our prime radiant machines, which goes out and gets all the collider data to be able to be used in the computational resources on the side. Now we also have this machine called the CRC DTN, which is our data transfer node. This is now what all our users use to transfer data from other organizations in and out. It runs Globus. So another university or whatever makes an endpoint, a Globus endpoint on their side, and we have our endpoint. And then our endpoint is connected to our Scratch storage space, which is a Panasys system, which is a network attached storage. So now when they go and pull or push data, it's actually coming out of the Panasys system, which is our 1-year Scratch system. So if you pull it from another university and dump it in your Scratch, at that point you have to go and copy it into our AFS system, which is a file system, but it's our permanent file system. It's backed up. That's where all your data lives forever. All our compute resources mount Scratch and AFS, but because of different tokens and authorization problems, Globus really isn't AFS compatible like most things, because AFS is a pretty old file system, but it's embedded here and it will be here for a long time. So you kind of have to do a double hop. But if you are running some type of computation, research, whatever, you generate a bunch of files, you want to move to another collaborator at another university, you can run it in the compute, which can write directly to that Panasys space, and then you can go and transfer it directly out through Globus on the DTN server. And finally, also running on this is our NDT server, which is our network diagnostic tool server. We have multiples of these, I think 6 or 7. There's another one in here. So they all talk to each other and can give you neat statistics and let you know when you're having problems or not. So our 100 gig, it made for very happy users. Now our physicists, I have seen a sustained 40 gig connection through those 5 Radian machines for a few hours at a time, which if we just had a 40 gig, we wouldn't be able to do that and everything else. So it is a good thing we have 100. I mean, when we get more machines on our 100, that will also be important, and we'll be able to up that up a little bit. I didn't think to save the graph when it went over 40, but here's one where that's definitely hitting over 20, and each block is an hour. So you can see where it's been going for over 20 for about 2 hours, but definitely over 10, which would have killed our campus, for half a day. And like I was saying, our other users that use Globus, our Globus users are usually pretty happy. They also use Globus to move data just within our campus every once in a while too, which is pretty interesting. They might have stacks of hard disks in their office that they want to put that information into our AFS system for persistent storage. And so they'll set up a Globus endpoint from their office and move data through that just within campus.
So we do have one question that came in. Could you repeat the name of your permanent storage location? John Paul wants to know.
Oh, our AFS system. That one.
Yeah,
Yes.
I guess that's what he was asking about. I'll just unmute you, John Paul. Okay, go ahead.
Oh, okay. So that was it's not a, okay, it's kind of confusing on the dates that I see on the bill, and I'm still having trouble viewing the bill.
John Paul, you may be talking to somebody different. I don't think we're looking at a bill over on this side. There, I'll mute you again. Anyway, yes, AFS was what I guess he was asking about. So go ahead, Steve.
Yeah, so AFS, that's in the VRF2. That's where all that storage is. And like I said, that mounts to all our compute resources, including the front ends, which our users can log directly into. So and it's mapped to their home directory. So when they log into the system, they're automatically in AFS. They really don't do like local storage on the systems unless they want to write to temp just for fast storage. But if whatever they write to temp, if it's important, they need to move it back to AFS when they're done computing. But like I was saying, AFS is permanent storage. It's a little slow. It's a little long in the tooth, but it is a distributed file system, so it works really well across all our compute nodes. And it does pretty well with small files, where our Panassa system, which is a parallel NFS sort of situation, works really well with large files that it can split up and write in parallel. But when you get into lots of small, tiny files, which our biologists like to do, it has a lot of problems with trying to keep up with small files. But like I was saying, our users are happy now. Everybody can move their data without crushing everyone on campus. And the campus is happy because the students can watch Netflix again, and the management can continue to do their interviews. So that was just a quick overview of our 100 gig installation and what it brought for us. I don't know if there's any other questions.
Well, I have a couple, but if people do have questions, just type them in the group chat, and then I'll unmute you. So let's see. I had a couple here. So NDT, of course, is dead or dying at this point, and it's not coming back. What are you guys going to do? Are you going to keep the NDT servers alive as long as humanly possible, or are you going to move to a different sort of performance tester?
I don't know what kind, because the NDT was kind of everything all in one tool, right?
Well, yeah, I mean, the benefit of NDT, at least what others tell me, I don't really agree with it because I think it was kind of old and bit rotted anyway. But it's the only browser-based tester that really exists that isn't something that hits the MLab infrastructure. So yes, there is a benefit in having that around. Just curious if you were going to try to either patch your own Web 100 kernels or just kind of leave them up in the current state once the support for that dies off.
I don't know. This would be more of a Rich question of what he wants to do.
Okay. Well, I'll bother him when he gets back from vacation then.
And I don't think Paul's on this call either. Those two would have a better idea of what the future of NDT is. Me, I'm just an engineer. I was, hey, we have NDT, go install this and make it work type of thing.
Okay. At one point you said you had 4 petabyte of storage. What is the current sort of usage of the 4 petabytes? Do you have a lot of headroom, or are you going to be needing to consider a lot more? Oh, I'm sorry. You said 4 petabytes of data. So yeah. The converse to that question would be how much actual storage is there if you already have 4 petabytes of data?
I don't know off the top of my head because this was just run off a report. This is probably all our AFS storage, our Scratch storage, maybe our backups, and a Hadoop cluster, I think, all in there to create that number. But everything still has room to grow.
And are the CMS physics people still the biggest users of that storage?
Of storage?
Yeah.
I don't know about that. And I would probably say maybe. Because there's a lot of data that's just generated within the CRC systems.
Okay. Are they the biggest users of the compute cycles as well?
Not always.
Oh, okay. That's surprising.
Well, we have a lot of chemists. Chemistry ends up a lot on top. We run a report every month just to see who our largest users are and what departments they're from. So sometimes it'll be astrophysics, sometimes it's chemists, sometimes it's high energy physicists. It can be all over the board. It can even be engineering every once in a while, running simulations.
Okay. Grace has a question. Grace, I'm going to unmute you and then you can ask. Go ahead.
I was wondering about any use cases that you may have had with the use of Globus and those details you mentioned in terms of the volume of data being moved.
I couldn't hear all of that. Jason, do you know what Grace asked?
Let me see. Maybe my okay. Can you hear me better?
Yes, a little bit better now, Grace.
Okay, thank you. I was wondering about whether or not you have had any use cases with the transferring of that data using the Globus tool across those DTNs you mentioned.
Use cases for Globus?
Well, for your purposes, have you had any problematic use cases? That's the key word, problematic.
Oh.
Has it smooth sailing?
So I would say the biggest problem with Globus is getting the users to create endpoints on their end is usually what we have. But as in flow of data, no. Our Globus guy is pretty good. He can probably hear me because he's right in the office next door. So I'll chat him up. Yeah, he's pretty good. Resolves problems pretty quickly, and I think everything was kind of set up well the first time for the Globus project. Okay. So yeah, I can't really say how much trouble we've had and what we had to do to overcome them. I can say that Globus is definitely is a good solution for us for our data transfer needs.
Okay, thank you.
Thank you, Grace. So I do have a follow-up along that line. You said that they have to double hop the data when they're using the DTN since it gets written to the scratch, and then if they're going to have it permanently live in the AFS, they have to do that. Has that been problematic for anybody, or are they just sort of used to it?
They're just sort of used to it. I mean, it's kind of, painful that you have to copy your data twice or whatever, but when we kind of explain why that is, they just kind of grumble and move on with it.
Okay. Cade has a question. Cade, I'm going to unmute you. Go ahead.
Yeah, I was just wondering if we could get a little more information on your DTN. Do you know, is it a single DTN with locally connected storage, or is it a cluster of DTNs?
Right now, it is just a single DTN machine server with the 10 gig connection out through the 100 and a 10 gig back to the network attached storage, which is the Panasas system using the Pan FS daemon to do all the writes.
Okay. Well, so then you were showing and saying that you were getting more than 20 gigs of throughput. So how are you getting that then?
The 20 gigs of throughput are mainly from the Prime Radiant machines.
Okay, so they're transferring it not through the DTN, but directly through their Prime Radiant machines.
Yes. So the Prime Radiant machines, what they kind of do are caching boxes of CERN data.
Gotcha.
That's used through the compute. So anytime the compute has requests, they'll hit the prime radiant machines and look for that data. And then if the prime radiant doesn't have it, it goes and makes a request up out to Nebraska or Chicago to bring it back. So when they do major syncs, that's when the 5 prime radiant machines can take it up over 40 gig.
Okay, that makes sense. Thank you.
No problem.
All right, thank you, Cade. So I thought of another one. Early on, you said when you first exceeded the 10 gig connection, was the campus only had the single 10 gig at that point? And if so, was that also a mixed connection with all the commodity traffic that comes off of iLight, or do you maintain a different commodity link?
I believe that 10 gig pipe kind of in here was commodity and research for everything. So they had dual 10s, but one 10 is more of a failover to the other.
Oh, okay.
And that's kind of funny you mentioned that, because about 3 years ago, we had a problem where different people started calling into OIT saying the network doesn't work. And they're like, no, it's perfectly, it's working. And they're like, no, we can't get outside campus. It turned out one of these 10 gigs was dropping 90% of the packets, but it wasn't a full failure, so it wasn't failing over to the one that was actually working.
Sounds like a perfect use case for Perfsonar.
So that was fun. Then when they finally figured out what was going on, they yanked this one and it flopped over and everything was back to normal. It turned out it was like an optic that went bad.
Okay. Anybody else have any more questions? I haven't seen any others come in yet. All right. Well, I think that we may have exhausted the questions. Thanks again, Steve, for presenting. And what we'll do, everybody, is we'll post the recording, and I'll send around the link to everybody. And Steve already sent me his slides, so they'll be in there as well. And if anybody does have questions for Steve, I'll CC him on that mail that goes out, and then you'll have his email address.
Cool. Well, thank you, everybody.
All right. Thanks, everybody. Have a good weekend. We'll talk to everybody soon.